today's edition of Subject Math. So today we'll be talking about algebraic processes. So before going into algebraic processes, we'll be talking about the expansion of algebraic terms. And before I proceed, I'd like to talk about this thing called algebra. Now, algebra is this branch of mathematics that deals with symbols and alphabet. Not just symbols, numbers, and alphabet. So that branch of mathematics that deals with alphabet, symbols, and number is known as algebra. Imagine me if I say a plus a. A plus a gives me a valid number to be 2a. Now, where what? This is a simple what? Algebraic expression. Where my a here has a coefficient of 1 and this has a coefficient of 1. So a plus a here gives me the value 2a. Now, explaining this further, if you ask me how come I'm getting the value 2, what is 2 doing here? If you pay attention, a plus a is common, I can factorize. Factorizing and bring out my a, this open bracket, 1 plus 1. If I should multiply it to take me back to this, so 1 plus 1 here gives me the value of 2a. Now this is a simple concept of what algebra is all about. But so let's talk about what expansion of algebraic terms. Talking about expansion, what is expansion? Expansion simply means opening of bracket. When I say opening of bracket, what comes to your mind? Expansion. So having this example, say x plus y multiplied by x plus 2y. And if you have an expression in this form, an expression in this form is known as what? Your algebra. So this becomes now what? X multiplied by x plus 2y, using x to multiply everything here, plus y, open bracket, x plus 2y. So at this junction, this x times x gives me x squared, x times plus 2y plus 2xy, plus x times y gives me xy, plus y times 2y gives me 2y squared. So at this junction, I can now say that what? X plus 3xy plus 2y squared is my valid answer for this kind of expansion. Now, look at this question from WAEC 2007, question number 43. The question said, expand the expression 3a minus xy in bracket 3a plus xy in bracket. So at this junction, what you do, you take your 3a to multiply everything through the bracket. So this becomes 3a open bracket 3a plus xy. Using minus xy to multiply everything in the bracket, 3a plus xy. So multiply all through. 3a times 3a will give us 9a squared plus 3a times xy gives us 3axy minus 3a times minus xy, that gives us 3axy plus xy times xy gives us what? Plus times minus xy in bracket squared. So at this junction, this becomes 9a squared, this is plus 3a, and this is minus 3a, so they cancel themselves, minus xy raised to power 2. So at this junction, breaking things down to this step gives us our final answer. Now, paying close attention to this question from your WAEC past question. This question from WAEC 2005, question number 5b, a theory question. And the question here said clearly that if m plus 1 and m minus 3 are factors of m squared minus km plus c, find the values of k and c. Now, looking for the values of k and c, that is, k and c in this expression are what we call constants. They are what we call constants. So since they are constants, so let's evaluate which becomes our solution here. Now, if they are factors, that is m plus 1 in bracket m minus 3 is equal to the expression m squared minus km plus c. Let's just expand using m to multiply everything here. M times n there gives us m squared. M times minus 3 gives us minus 3m. Plus 1 times n gives us m. 1 times this gives us minus 3 is equal to m squared minus km plus c. So this becomes that m squared minus 3m plus m will give us minus 2m minus 3 is equal to m squared minus km plus c. Rather, I'll call this equivalent. Therefore, at this point, there's what we are going to take the step of comparing coefficients. Comparing coefficients. So comparing coefficients is, so m here is compared to m here. So I have minus 2m here is being compared to minus km. M cancel m. So at this junction, minus cancel minus. So k here is equal to 2. Now, at last, we then have minus 3 here is equal to c. Therefore, k is equal to 2 and c is equal to minus 3. So this one past question has been able to what? Justify the solution to this particular expression. Now, this question, find the coefficients of m in the expansion m minus 1 whole over 1 over 2 and or m plus 2 over 3. So at this solution, at this point, we evaluate that m minus changing this to improper fraction, 2 times 1, 2 plus 1, 3 over 2 in bracket multiplied by m plus 2 over 3. So we can now expand here. M times m, which is m squared, m times this is plus 2m over 3. This times this is minus 3m over 2 plus this times that is 6 over 6. So this becomes like m squared plus open bracket. The LCM here is 6. 6 divided by 3, 2. 2 times 2, 4m minus 6 divided by 2, 3. 3 times 3, 9m. Close bracket plus 6 divided by 6, 1. So m squared plus, okay, proceed, f4m minus 9m, which is going to give us minus 5m over 6 plus 1. Now, at this junction, the question said, pay attention to the instruction, find the coefficients of m in this expression. Therefore, in your expression here, the coefficient of m is equal to minus 5 over 6. So it being minus 5 over 6, that leads us directly to our final answer. So it is now, we move further to factorization. Now, factorization is simply the reverse of expansion. If you're asked to factorize, you have to return back that expression back to its expansion form using what its common factor. Now, look at this expression from 2010, question number 12. So they said, factorize x plus y minus ax minus ay. Now, pay attention. These two have something in common. These two have something in common. Now, what does these first two numbers have in common? They have what? Plus 1. So bring out 1, open brackets, x plus y. Now, breaking this out, these two numbers, what does it have in common? They have minus in common. And also they have what? A in common. So, factorizing this becomes x plus y. Now, let me explain how this is x. We have minus ax. Since we brought out minus a out, this cancels, so left it on x. This is what? Minus ay. Since we brought out minus a out, this cancels, this cancels, we left it on y. That's now we have positive x, positive y in this expression. Whenever you are factorizing, please pay attention. What is here should be the same as what is here. If you're having sign difference, then there is an issue. There shouldn't be any sign difference. So at this junction, you pick this particular one to this, that is 1 minus a, and also pick this particular one, x minus or x plus y. And this gives us our final answer. Now, if x minus a in bracket is a factor of bx minus ax plus x squared minus ab, find the other factor. Having this kind of question, Now, please let's pay close attention. This question is from WAEC 2014, question number 18. You can check your past question for confirmation. So, I can go forward now to be. Now, first and foremost, I will say, as a student, you have to bring this out, which becomes bx minus ax plus x squared minus ab. Rearrange. You have to rearrange to make it easier for you to express or factorize. So this becomes x squared. These two have something in common. Minus ax, yes, plus bx minus ab. So at this junction, the first two variables have something in common and the last two have something in common. So what does the first have? They have x in common. So factorizing your x out, it becomes x minus a. What does these two have in common? They have what? Plus b in common. So bringing up b, it becomes what? X minus a. Pay attention, what is here is the same what is here. So I say that x plus b, x minus a. So at this junction, I have factorized and that is my final answer. So, pay close attention to this. Factorize 50k raised to the power 4 minus 8b raised to the power 2. Now this question, first and foremost, is going to open us to what they call the difference of two squares. So the difference of two squares, let me quickly explain that. If I have x squared minus y squared, as far as there are two squares, this can be expressed as x plus y, x minus y. Now this is exactly the difference of two squares. That is, if I should expand this expression, it will take me back to this. Let us expand for better confirmation. X times x here gives x squared. X times this gives minus xy plus y times this as plus xy. This times this as minus y squared. So at this junction, I have what? Minus xy plus xy. So this can cancel out. Then I left with x squared minus y squared. Now, paying attention, this expression can be this, and this expression can be this. So, what's better of understanding this particular expression? So, we're going to be using its idea to solve this particular NECO question that came out in the year 2007, question 16. Now, the question said that 50k raised to the power 4 minus 8b squared. Now, look at these two expressions are not perfect square. Well, I can break them down. Break them down by bringing out 2. If I should bring my 2 out from this expression, they become perfect square. 25k raised to the power 4 minus 4b squared. So because of these two lines, I factored out, made this expression a perfect square. Therefore, I can continue by saying that 2 open brackets 5 raised to the power 2 k raised to the power 4 minus 2 raised to the power 2 b raised to the power 2. So I can further say that this is 5 what k raised to the power 2 open bracket raised to the power 2 minus 2b raised to the power 2. So at this junction, I've been able to express this in this form. So I can now take the difference of 2 squared. This becomes 5k minus plus 2b in brackets 5k plus 2b. So at this junction, I'll be able to say that I have factorized this particular expression completely, and that becomes my final answer. If you pay attention to this question closely, you have what? X squared plus 7x plus 10, and you're asked to factorize completely. In this kind of question, it is very, very easy. You pick the first term, multiply it to the last term. Multiplying these two, it gives us 10x squared. Look for the new factors of 10x squared. So you have here 2 here, 5x squared, 5 here, x squared, x here, x here, 1. Now you ask yourself, how do I combine these new factors to give me b? So combining these new factors is the main thing. I can say 2 times x, 2x, 5 times x, 5x. That is 2x plus 5x will give me 7x. 2x times 5x will give me what? 10x squared. If it can satisfy the condition of addition and condition of multiplication, if it can satisfy these two conditions, therefore you can use it to replace your b. Therefore, this expression has satisfied that condition. This becomes that x squared plus 2x plus 5x plus 10 plus 5x. So this becomes this. What is common here is x. So bring my x out. This becomes x plus 2. What is common here? You have plus 5 here. Bring out x plus 2. 10 divided by 5 gives me 2. That's how 2 came into the expression. So don't forget, what is here should also be what is here. Therefore, I can now say that x plus 5 is the same in since x plus 2, x plus 2, I pick one of it. So at this junction, I've been able to factorize my expression completely, and we have x plus 5, x plus 2 as our final answer. Now, look at this question on what? Algebraic processes. Question from NECO 2006, question number 27. It says that if 2a minus 3b over 3a minus 2b is equal to 4, then evaluate a square plus b square all over 2ab. Now, picking this expression first, 2a minus 3b over 3a minus 2b is equal to 4 over 1. At this junction, cross multiply. This becomes that 2a minus 3b is equal to 4 open brackets 3a minus 2b. So this becomes 2a minus 3b is equal to 4 times 3 here give us what? 12a minus 4 times 2 give us 8b. So at this junction, bring all b to one side. This becomes okay, bring it all b to one side. This becomes 8b minus 3b is equal to 12a minus 2a. 8b minus 3b, that gives us 5b is equal to 12a minus 2, that gives us 2a. So b here is equal to 10a over 5. Now, if b 10a over 5, I can now bring my answer to be b here is equal to 2a. Now, since my b is equal to 2a, what did the question say? The question said evaluate completely the a squared plus b squared over 2ab. Now, since my b is now 2a, this becomes a squared plus, instead of writing b, I'll now write 2a squared over, this becomes what? 2a open bracket, okay, 2a open bracket 2a. So I can now evaluate this further to give me a squared plus 2a squared, that is 4a squared, over 2a times 2a, that will give us 4a squared. Now this is equal to a squared plus 4a, that will give us 5a squared over 4a squared. So my a squared cancel my a squared. This is now equivalent to 5 over 4, or 1 whole number 1 over 4. And so that is where my answer finally goes to B, and that's our final answer. Okay, solve the equation 3b over 9 plus 1 over 2 is equal to 3 over 4 plus b over 4. Now, solving this equation, first and foremost, we'll have to what? Solve these two. So what's our LCM here? Our LCM here is 18. 18 divided by 9, 2. 2 times 3, that's 6b, plus 18 divided by 2, that's 9. 9 times 1, 9. Is equal to, at this junction, my LCM here becomes 4. 4 divided by 4, 1. 1 times 3, 3, plus 4 divided by 4, 1. 1 times b. So at this junction, cross multiply. This becomes 4 open bracket, 6b plus 9 is equal to 18 open bracket, 3 plus b. So at this junction, 2 is common, divide both sides by 2. 2 cancel, then this becomes 2 open bracket, 6b plus 9 is equal to 2 here, 2 cancel here, that's what? 9 open bracket, 3 plus b. So at this junction, I can expand. 2 times 6b gives us 12b, plus 2 times 9 gives us 18, is equal to 9 times 3 gives us 27, plus 9 times b gives us what? 9b. So collecting like terms here, this becomes 12b minus 9b is equal to 27 minus 18. So 12b minus 9b gives us 3b, as 27 minus 18 gives us 9. So b here is equal to 9 divided by 3, and b here is equal to 3. So in this question, NECO 2007, question 14, b there is equal to 3, and that is the final answer. Now, 3 over 2 in open bracket x minus 2 minus 2 over 3x minus 2 is equal to 0. And here, what are you to do? What? Solve the equation. First and foremost, I would like us to evaluate the denominator. This becomes 3 over 2 times x, 2x minus 2 times 2, 4, minus 2 over 3 times 2, 6 minus 3 times x, 3x is equal to 0. So at this junction, what is my LCM? My LCM is 2x minus 4, 6 minus 3x. This is our LCM. So this 2 divided by this gives us this. So this time this gives us 3 open bracket, 6 minus 3x close the bracket minus 2 open bracket. So this divided by this gives us this. This time this gives us 2x minus 4 is equal to 0. So at this junction, I can expand this. So expanding it becomes 3 times 6 gives us 18, minus 3 times 3 gives us 9, minus 2 times 2x, that gives us minus 4x. Yes, minus 1 times minus gives us plus, 2 times 4 gives us what? 8, all over our denominator, which is 2x minus 4 close bracket 6 minus 3x, don't forget it is equal to 0 over 1. And this junction cross multiply. Cross multiply, you now have that 18 minus 9x minus 4x gives us minus 13x plus 8 is equal to, everything here times 0 gives us 0. So at this junction, we collect like terms. This becomes minus 13x is equal to minus 18 minus 8. This becomes minus 13x is equal to minus 26 minus 26. So at this junction, divide both sides by 13, divide both sides by 13. So 13 cancel minus 13. So minus cancel minus, so x here is equal to 13 here 1, 13 in 26 twice. So this leads us to our final answer, which is x is equal to 2. Now, we have a simple equation here, a very simple linear equation, so we will have to solve this. So, solution. So, firstly, we will expand. Expanding this gives us 6x, that is 3 times 2x, which gives us 6x, minus 3 times 7, which gives us 21, is equal to 2 times x, which gives us 2x minus 2 times 8, which gives us 16. So collecting like terms here, which is very easy. Collecting like terms, it becomes as 6x minus 2x is equal to minus 16 plus 21. So pay close attention, 6x minus 2x is going to give us positive x is equal to 21 minus 16, which is going to give us 5. So divide both sides by 4. This cancels out, so x here is equal to 5 over 4, or you can change it to mixed fraction to be one whole number, 1 over 4. I believe you must have gone through fraction to understand how this came about to be one whole number, 1 over 4. So, coming to the end of class, we've been able to have touched a lot, and now we'll have an exercise to back up what we've learned. So we have factorized this, which is a NECO question, 2009. We have, and this is the solution. After you finish trying, you find your solution. And we have this factorized completely, which is a NAPTEP question. We have this particular number 3 here, which is a white question, 2012, a theory question, question 7b. And finally, we have the final question, which is a question from white past question, 2008, question number 12. And we have its answer, which says factorize 5y squared plus 2ay minus 3a squared. So, try as much as you can to practice as many questions as you can.